In this video, we will finish up our discussion of improper integrals of the second type by evaluating a few more examples. So let's look at the integral from 0 to the natural log 3 of the function given here. So these improper integrals of the second type can sometimes be a bit more subtle to recognize. Looking at the lower limit 0, we note that e to the 0 is 1, 1 minus 1 is 0. So we have this infinite discontinuity that occurs at x equals 0. This is an improper integral of the second type. So we rewrite it as a limit. It will be the limit as t approaches 0 from the right of the integral from t to the natural log of 3 of e to the x over the square root of e to the x minus 1. Now, in order to evaluate this limit, we hopefully recognize that the e to the x minus 1 in the denominator can play the role of u, and e to the x dx would play the role of du. So, substitution-wise, we'd be thinking u equals e to the x minus 1. However, without actually going through all the details, let's just write down what this antiderivative will be. So in terms of the u substitution, it would be 1 over the square root of u, whose antiderivative is 2 square roots of u. So it would be 2 square roots of e to the x minus 1, evaluated from t to the natural log of 3. And of course, one could go through and verify with the substitution, or check this via a differentiation using the chain rule. So we now plug in the natural log of 3, put a minus sign, plug in t. So 2 square root e to the ln of 3 minus 1 minus 2 square roots of e to the t minus 1. So remember, e and the natural log are inverse functions. So we really have underneath the first square root 3 minus 1 or 2. So this would be the limit as t approaches 0 from the right of 2 square root of 2 minus 2 square root of e to the t minus 1. And note, as t approaches 0 from the right, e to the t itself is going to 1, and the square root of 1 minus 1 is 0. So this second piece is approaching 0, and the limit of a constant is that constant. And now one last example. The definite integral from 0 to 3 of 1 over x minus 1 to the 2/3. Because of the x minus 1 appearing in the denominator, this will be an improper integral of the second type, and that infinite discontinuity that takes place at x equals 1 is in the middle of the interval from 0 to 3. So we're going to have to break this up into two separate integrals. This will be the integral from 0 to 1 of 1 over x minus 1 to the 2/3 plus the integral from 1 to 3 of 1 over x minus 1 to the 2/3. And in order for this improper integral to converge, what we need is for both of these resulting integrals to converge to some finite number. If either one of these were to diverge, then the original improper integral would also diverge. So let's just start with the first integral, evaluate, see what happens, and if it converges, we'll evaluate the second. So because of that discontinuity at 1, we're going to write this as the limit as t approaches 1 from the left of the integral from 0 to t of 1 over x minus 1 to the 2/3. The antiderivative of 1 over x minus 1 to the 2/3 is 3 times x minus 1 to the 1/3. So that would be the limit as t approaches 1 from the left of 3 times x minus 1 to the 1/3 from 0 to t. And just to give you the intuition here, remember that having 1 over x minus 1 to the 2/3 is equivalent to x minus 1 to the minus 2/3 power. Minus 2/3 plus 1 gives you the 3 and the 1/3. So plugging in x equals t, this would be 3 times t minus 1 to the 1/3 minus sign, plug in t equals 0. So this would be minus a minus 3. And as t approaches 1 from the left, t minus 1 goes to 0, and because of the positive power, this first piece goes to 0. And the value of this limit would be positive 3. So because the first improper integral, when we've rewritten it, converges to a number, 3, there's a possibility that the original improper integral converges. But it now all depends upon the second remaining integral. So similarly, let's evaluate. So the infinite discontinuity is at 1, so we'll say the limit as, now we'll call it s, approaches 1 from the right, of the integral from s to 3 of 1 over x minus 1 to the 2/3. And recall that there's nothing special about using s or t. We just as easily could have used a, b, or any other letter or symbol that we prefer. So now the antiderivative of 1 over x minus 1 to the 2/3 is 3 times x minus 1 to the 1/3. And we're evaluating from s to 3. So we plug in x equals 3. So when we plug in x equals 3, we have 3 times x minus 1, which is 2, then raised to the 1/3 power, and we're subtracting away when we plug in s. So now, once again, thinking about what happens to the term with s. As we approach 1, 1 minus 1 is 0, and since that's raised to a positive power, as s approaches 1 from the right, that limit is going to go to 0, and what's going to remain is simply the constant 3 times 2 to the 1/3. And this gives us the value of our definite integral, 3 times the quantity 1 plus the cube root of 2.